Hi everyone, I'm Zarrar. I'm a coach at Interview Query. I'm very excited to have Xinyu here to go through a machine learning kind of systems design case study. And you might, encounter this often on your interview journey. And in particular, we'll be looking at a question called minimize wrong orders. And so it's a question where you're imagining you're a data scientist at DoorDash. You're building a machine learning system that minimizes missing or wrong orders placed on the app. I'm sure probably most of us have used either DoorDash or other related apps, and we've probably had, something missing or something wrong on the app, and it's extremely frustrating, right? Because you're waiting for this food and you get it and it's totally wrong. Not again! And that's when you're supposed to eat. It's a pretty bad experience, and so it's something you can imagine that companies like DoorDash would want to minimize this from happening.
Can you fix this?
And so what we'll be discussing, or Xinyu will be going through, is how to go about building the system to minimize these missing or wrong orders placed on the app. Okay, Xinyu, can you introduce yourself and just share with us your background, expertise, what you hope to achieve from this session?
I'm a PhD in statistics, and currently I'm working as a data scientist. I'm interested in recommendation system. This interview session, I want to get more experienced in the interview in machine learning system design, and I want to polish the skills in the communication with interviewers.
Thanks, Xinyu. That's a very interesting background, and I'm also excited about recommendation engines as well. And yeah, hopefully, some of your interests in the machine learning systems design interview, we'll be able to cover that in this session. If you could share your screen now and just go through the question for us.
Okay, let's say you work as a data scientist at DoorDash. You are tasked to build a machine learning system that minimize missing or wrong orders placed on the app. How would you go about designing the system? To start with, I have some clarification questions. If
Okay.
First of all, do we know what's the cause of the missing and wrong orders already?
So you're saying like what's the cost to the business?
Yeah.
Yeah, I guess you could have that information in a table, right? That's something you could get, sure. You basically have access to a table in a database, right, that has information about each order, and you have existing data, where the missing order or wrong order has taken place. And then, yeah, you have that information. You might also have information where, the customer might be refunded the amount or given additional money. So often, DoorDash will, if they've made an error, they might give you additional money as well. So yeah, you'd have all that information in some kind of table. It's a good question. Yeah, I think you would have access to that data, that whether something has been missing or wrong, and whether, they've been refunded or they've been given additional money, as some policy.
What I'm really interested is the cost of the wrong order. Is that something on our side, maybe data storage? What do you think is the cost of the wrong orders?
Yeah, I mean, I feel like
Or I
you
mean
should.
cost.
Oh, cause. Oh, cause. I thought you said cost. I see. I see. Um, uh, right. Yeah. So that's some. So what do you think the cause could be? I mean,
Um,
I, I think. I mean, so I told you we do provide you with the information with the tables that something has
mm,
gone wrong, but you're a data scientist, so I think this is would be part of your thing to find out the causes. So it's a good question, but I feel like it's something maybe you can come up with some options and
yeah, I'm thinking several situations, like maybe the first is the client accidentally use the old address, and then in that case that is the user's responsibility. And another thing maybe is a restaurant, they misread the notes and they gave the wrong food, and in that case it's uh at the restaurant level, we should just do some data. Okay, the
yeah,
problem could be also be on the restaurant, and
yeah, that's good.
or maybe it's in our system. When we transfer data, somehow some error was generated.
Yeah, this is perfect. I mean, you basically gave in specific examples, and then, I mean, you've also given the general problem. So user responsibility is one category, restaurant responsibility is another category, and then I guess the other one is DoorDash. I think that would cover Yeah, that would cover the causes of the wrong order.
And on our system, I think we can maybe only catch the system issue.
Oh, mm, well, um, is that true? You think, I mean, you can, I
Okay.
mean,
You want me to think about to the other scenarios as well to take.
no, I mean, you don't, I mean, it's usually for these questions, you can always say, I'm going to focus on this one issue. But I do think it's possible for, the other issues to be identified. Um, but maybe not directly. But I think it's possible, right? Like
Okay.
with the restaurant level, couldn't you do some things to kind of get at that? Um,
Yeah, for the restaurant level, maybe we can, if there's repeated errors, same
right.
errors happens in a short time, we can remind the restaurant
Y-
to pay more attention to it.
Yeah, exactly. Exactly.
And for
So
the user's side, maybe we can detect their address and their location and ask them to confirm the address.
yeah, exactly. Yeah. And I guess usually for these things, when there's a missing or wrong order, usually some kind of ticket is created, right, from the customer side. So you might have information, like the customer might provide that information, like, it was supposed to come here and it didn't arrive or something. So uh, maybe on some level you might have that information as well.
Mhm.
Yeah,
Yeah, I'm thinking for different cause of this problem, the system can be very different, right? If we want to build a one like comprehensive like system for everything, I think that can be challenging. Maybe we can just focus on one issue for now and
sure.
try to expand it
Okay.
as we move forward.
Sounds fair.
Let's say, yeah, we'll focus on one issue and which is the maybe the system issue. We it's not system. I'm thinking we can just check the order in our system before okay, when the order is made, we check we double check it in our system to make sure it's there's nothing wrong with it.
Yeah,
Right.
yeah. I mean, I think this kind of question that you're going down sounds more like a software. You're just checking that the system actually works. So actually, but there's no machine learning involved there, right? You're not making any predictions or anything, or are you?
Yeah, I'm thinking about using some machine learning models that just um is we want to incorporate all the informations uh in real time and make a prediction on whether this information about this order is right or wrong.
And so the system issue is like when the order is placed by the customer, the restaurant, for whatever reason, gets something wrong. Like there's some error that occurs at like a programming level. Is that right?
Mm, uh, let's focus on one issue for now. Like maybe now I'm thinking about building a model at the beginning of this process. When the order was made,
Yes.
when the yeah, in real time, I check whether the information about this order is right or wrong.
Yeah, yeah, that's right. And we'll have that information, sure. Yeah.
Yeah, and after after the order was made, that there could be somewhere else, some other issues happen. And for now, I'm not taking them into consideration in this system. They could be like in the next step, we can design another system or expand the current system to cover those cases.
Sure.
Okay.
And so
So
how, and one other thing sorry, were you going to say this or were you going to say next?
I'm thinking about moving forward. Oh,
Yeah, sure.
okay. Um, then we can let's say this problem is to identify wrong orders and what is the success of how do we define success?
Yeah, perfect. Oh yeah. Sorry, I pressed enter.
Yeah, you want
Um,
to
no, no, go
taking
ahead, go ahead, go ahead, go ahead.
from framing maybe define success.
Yeah.
I'm thinking this is a binary classification, so what we should care about is precision and recall. And I'm trying to figure out which one is more important in this case. I think both are important, like both precision and recall are important in this case because
Yeah, let's say like our model, like when you run the model, it
mhm.
flags something, but then you have someone else that confirms it. Like say the point of this model is it makes a prediction, but then someone either at DoorDash or at the restaurant is going to check what the model says. So let's say that's the use case.
Oh, that's the use case. Great.
Let's say that's what it is. Mhm.
Okay, so if that's the case, it's okay to generate some false positives.
Exactly.
And yeah, because the some support team will check our result.
Yeah,
Um,
exactly.
good.
What do you think would happen? So if we didn't have that, then we probably wouldn't want false. But like if it went straight to the customer, then we
Then
wouldn't
we
want it. Yeah,
yeah, we wouldn't want it because that will cause some confusion to the client, to users.
perfect. Yeah, yeah,
Um,
yeah. Okay.
Good. I think recall is more important in this case. Just we want to detect all as many positives as possible.
Yeah, that's right.
And then let's move on to the data we can use.
Yeah, sure.
We have the client data, user data. Those include the client, the user's payment, address, and the order value of that order. I think people usually they order from, like their order value won't vary a lot. Yeah, if there's a one order that's extremely large, maybe there's some problem with it. And also we have some restaurants data, including the address. If the address, if the restaurant is very far from the user and that's not, maybe the user is using a wrong restaurant.
Yeah. And
Or maybe yeah, there are many other ratings or many other data about the restaurant. And there can be contextual data, including the device, time of day, yeah, etc.
and we can also have data on like number of times. Like you could probably have features for number of miss times that a restaurant has had a missing thing and a user as well. Like you can have
Okay.
aggregate data. I think we talked about that, right? That there can be data about the user, like historically this user has like,
All right. Yeah.
like two out of four error, like, what's the percentage of times or whatever. It can be some metric measure, right? In the restaurant too, like
Yeah, they're the user's previous
yeah,
interaction with on our web on DoorDash.
yeah,
Uh, yeah, and also demographics.
yeah. Yeah, I think that sounds good. I like how you've broken it down. The categories are pretty good, like user, restaurant, and contextual. I think those are nice categories that you have there.
Thank you. Uh, and yeah, and also we also need to know the labels. Yeah, like we said previously, we have a either based on the client user's report or from our system itself, we have identified the wrong orders. So for the historical data, we already have the label. Yeah, it will be 0 or 1. So and for features, we most of have been covered in what we just said. And
Yeah, yeah, you already discussed the features.
features. Okay, then let's move on to the models. And first we want to the model selection. This is a binary classification, so the most simple model may be logistic regression, but there are
Right,
many limitations of it. It only can capture the linear relationship.
right.
Yeah, actually, when we are in the features, we have some continuous features. So I want to come back to this step before we move forward. Continuous features is they will be easy to use. But maybe like for some features we may want to categorize them, like age. We may more interested in the age range instead.
So you're making it categorical, or you're keeping it
Yeah, I'm
as
thinking making them categorical.
okay.
Yeah,
Yeah, I mean,
yeah, and for the categorical data, and we will need to encode them. And the simplest is one-hot encoding.
sure.
Yeah, but for if we have some textual data, it don't seem we maybe on the restaurant level there could be some textual data, and we can use word encoding.
Okay.
Or the client may leave a comments in the
Right.
leave on order something to pay. Yeah, also
Um,
the
yeah,
yeah
that's
they
clever.
leave
Yeah.
some comments on the
Right.
system, so
Right.
we can use word encoding. So far, yeah. Just now I think we can this is how we use the features. And then in model selection, like I mentioned, linear regression is the most intuitive way, but there are some limitations, such as it cannot capture nonlinear relationship between the
Yeah.
predictors and response.
Yeah.
And if to make it
Mm.
to make the model to be able to capture more complex patterns, we may want
Right.
to use like tree-based models like
Yeah.
gradient boosting.
Yeah, exactly. Yeah, it makes sense.
Mm,
Yeah. You can also get like interactions with that as well.
yeah, exactly.
Mhm. Mhm.
Um,
Okay. I mean, I think that sounds reasonable. You could do both of them, right? You could try one and try the other. That seems fair. Would you consider doing a neural network in this case?
I'm thinking, yeah, we can. It's an option, and I think the main concern is the amount of data we have. Yeah, there could be a lot of orders, but how many of them is wrong orders? It can be very rare. If that's the case, even though there are a lot of orders that we can't consider as big data. But that's just one thing we want to consider. And also the time to train the model
Right.
and the computation, the amount of computation.
Yeah, that's fair. Okay, so then for next, so you selected the model. Can you kind of describe how it would work from kind of end to end, given you've already said all this stuff, but just
I'm sorry,
some.
I'm distracted. Can you say it again?
Oh, I was saying, so now you've listed all the elements. Can you just kind of describe how you would do it end to end quickly?
End to end.
And then also talk about, sorry, also talk about I mean, you already talked about recall and stuff. So yeah, if you
Mhm.
just, put it all together, like, from beginning to the end of the model to its predictions.
Okay. Let me try. So I think when this order is put on the user's end, we have
Yeah,
collected, we have received the information um, about this order. We have the user's data, we have data from the restaurant, we have
yeah,
some contextual data, and we want to predict if this order is problematic or not.
right.
Then we okay to sorry, I'm a little confused when you said end-to-end. End-to-end is to design
Me-
this things.
No, no,
It's
no,
not.
sorry. Basically what I'm saying is that you've described all the pieces. So, just you've already given everything in the pieces. So can you just say, I mean, you already started to describe it, right? So you said, okay, I'm taking in the data, then the user makes the query. So we have this data, we then make a prediction, and then what do you, because you mentioned the recall earlier, but after you selected the model, you train the model, then how are you just so you're using recall, right, to optimize
Mhm.
the model, right?
Yeah.
There's like
Um,
because you have to do like hyperparameter optimization for some, I mean, for
yeah.
regression and gradient boosting.
What I said earlier is some online, what happened online, but I think model training will first happen offline.
Yes.
So I want to like let's say what happened offline.
Yes.
Offline when I want to train the first version of this model, I need to collect the data we have in the
Yes.
history.
Yeah.
And the features include what we just said, the
Exactly.
user's data, restaurant,
Exactly.
etc.
Exactly.
And we already know the labels. So we
Yeah.
use that information, we can build a model. And when the
Okay.
model training, of course, we will divide the split the data into training, validation, and test set.
Yeah.
And preferably we use the later data as a test set.
Okay.
So
Perfect.
that is like using historical data to predict the
Yes.
future.
Exactly. Yeah. Great.
And the validation set is, of course, to use it to tune hyperparameters. No matter
Yeah.
which type of model we use, we need to do this.
Exactly.
Mm,
Okay.
and
Okay. So that's good.
yeah,
So
I'm
yeah.
sorry about them. I got a lot of messages from work.
Uh,
Okay,
yeah, I
it's
think
okay.
that's good,
I can move
right?
forward.
Yeah, so can we just move forward to the next step? Mhm.
And now we have a model. After a testing, we know how good it performs, like in terms of recall and precision, and all the metrics we care about.
Yeah.
Um, and and then we decide to or maybe deploy it.
Uh, but how would you know whether the model's what
Good
might you
enough.
do before deploying it?
Um,
How would you decide whether it's good enough to deploy?
yeah, I'm thinking is there a baseline that we can compare to? The baseline could be how we deal with the wrong order, how we detect the wrong orders right now in the system.
Yeah.
If
And what
there's
about
no
like,
such,
sorry, go ahead.
I mean, if there's no such detection at all, then it's better to have one no matter what. Is that right?
Yeah. And then what about doing like an A/B test, right? Do you think that's
Yeah,
something we could do here?
yeah, of course.
Mm.
To launch this model, we can do a A/B test, and
Okay.
for this model, we can like maybe expose it to a very small population to begin with, and it
Mhm.
works fine. Or
Yeah.
yeah, just add the population step by step until we
Yeah.
think it's stable and is at the same time we monitor its performance and to make sure it meets the criteria to launch it to the whole population.
Okay. Yeah, that sounds good. And if you did do an A/B test, how would you consider the time taken to do the test and the, amount of customers to include in the test and what are your treatment groups and stuff like that?
Uh, so is that your question about
Yeah. Like if you we yeah.
how to
Yeah, if we
select?
did
Sorry.
yeah. Yeah, so one question is like how would you select the people, the number of people to include in an
Mm,
A/B test? Mhm.
okay, one thing we can do is random selection.
Uh-huh.
Um, we just decide what percentage goes to the treatment, and we
Right.
can do random allocation.
Right.
Yeah, and then
Okay.
yeah, what
Yeah.
you're asking.
And then the other question was, so how long would you run it for?
I think that depends on the metrics we care about. If and see if there's a significant change.
Okay.
Given yeah, based on how many data we want to collect to get a significant result. To be oh sorry. It depends on how many samples we want to collect in order to achieve the power to detect the difference we want to detect.
Yeah, exactly. Yeah, that's it. Um, okay. And then what are some of the metrics we would be considering? I mean, I know you talked about recall, but from the business side of things, what are the metrics we would be looking at?
I think one thing is the client satisfaction. There could be survey uh, when the user check out their order and they may leave a feedback. If
Mhm.
it takes too long to detect, maybe the client will be unsatisfied with their experience.
Okay.
And also,
Oh, sorry, I forgot to Right.
We also want to make sure there's no impact in the revenue. Of course, it's not likely, but we want to maybe as a secondary metric, we want to monitor that.
Yeah, that makes sense. So
Yeah.
revenue makes sense.
Mm-hmm.
Okay. Okay. I think yeah, I think that sounds good. What do you think?
And also maybe we want to monitor, or we also want to look at um, the amount of work for the customer support group. They will manually check the order, and very likely this system will save them time to achieve the work,
Uh,
achieve the goal.
right, because you're if this system works, then it saves time on the support staff, right?
Yeah.
Uh, okay. And
Okay.
sometimes it's helpful to just very quickly in one sentence, like just wrap up the question and how you would do it.
Oh, wrap up which question?
Yeah, I think we've covered everything. I was just wondering, like sometimes did you want to just I think normally like if you did this, you might, end it by saying like, here's a 1, 2 sentence summary of kind of what I said I do.
Oh, okay. Yeah, to launch the model, we need to run an A/B test to verify it's helpful. Um, so in the A/B test, we can do a randomized allocation, and we add the population to the treatment group step by step, and at the same time, we um, monitor the performance of the treatment group. And yeah, what else?
Yeah, I mean, I think you covered most of it, right?
Yeah, and the metrics we want to monitor include recalls and the customer satisfaction and revenue and the workload of the customer support group.
Yeah. Yeah, it makes sense. Yeah, sounds good. So I think should is there anything else you think we should add to stuff,
Yeah.
or do you think it would?
So this is like I said, the very first version of this model. And to iterate it, we may also want to continue learn this model with most fresh data. There are several ways we can do that. Like we can regularly retrain this model, maybe on a daily basis or hourly basis,
Yeah.
uh, to capture the most recent cost of the wrong orders. And also we can maybe, yeah, I think that's it. Um,
I think that's good. I mean, from my standpoint, I mean, I liked that your clarification questions were good. I liked, that you broke things down into, where we could have issues occur. You framed the problem well. The one thing I think early on you could have stated what the like high level metrics were, like revenue. You could have stated it earlier, I think, that revenue was important and customer satisfaction was important and stuff like that. And then you mentioned the time of the customer support, which is very interesting. I don't know if everyone would think of that, so that was good. But yeah, I just think that these points you could have brought in earlier to frame the
yeah.
problem. But otherwise, yeah, it was nice. You stated, the data. I think you went through it pretty clearly. I liked that you brought in the comments that the user had. I think that was a nice touch. Maybe not everyone would have thought of that, but including that in the data was good. I think it was nice that you considered the different types of data, like continuous, categorical, and then you also had the embeddings, word encoding. So that was good. And you went through the models pretty well. I mean, I think since the data set's fairly large, I don't think there's some issues that might come with smaller data sets. But you did mention that, the issue where the missing orders might be rare and infrequent. So for each type of missing order, we might not have too many. I think that was a good point that you made. And then you did talk about the model training, train validation test. I think the A/B testing you should have said sooner after that. But you did mention it, and I think you said everything, you know, how we have to do the A/B testing and stuff, and we have to do a power analysis to determine the amount. So I thought that was good. Yeah. The only one other thing, I don't think you needed to do this, but it could be helpful, I think, is imagining which you sort of did. I think at the beginning you did, like, what's the user experience? So like, the user sits down, what happens? Like, what's the user journey? I think sometimes going through a user journey of what goes wrong can be helpful. I think you did mention all the issues, but I think it could be helpful mentioning a very specific case where a user sits down, they order
Mhm.
something and it gets wrong. So I think being more explicit about the user journey. But again, you did say it, so I'm not saying that you didn't. You did mention
Yeah,
issues that the user made, but
uh,
just saying something about the user journey. So yeah, I think that was my kind of assessment of it all.
thank you for
Uh,
the feedback, sir.
yeah.
Yeah, I feel like there are many things out there, and I don't have a like order which one I should mention first. It's not. Yeah, I should maybe work on that later.
I mean, I think there's just two things. One is the high level metrics you should have mentioned earlier, and I think the
Yeah,
other is the A/B test. Yeah,
got you.
yeah, but you're right. If you just have the order in mind, then because you knew everything, right? So I mean,
Mm,
it's just a matter of because these are interviews, so we're not used to doing this in our real work, right? I mean, we do all these steps, but we don't necessarily do them in half an hour. So, yeah, I think. Otherwise, it seemed pretty good to me. I mean, it definitely
thank you,
seemed like you
sir.
you you knew everything. And then what do you think? What did you learn from solving this problem? Did you have
Um,
anything?
I learned from solving this problem. Yeah, this problem is really vague to me at first.
Mm,
Like there are many different causes of wrong orders,
yeah,
and each one might need a different type of model to detect. Honestly, like there could be fraud, there could be like just the careless of the people in the restaurant. They made it wrong. So each type of model, yeah. So while I'm working through it, it's I think it's very helpful to narrow down to a one specific area to work on to start with, and later
yeah,
we may want to generalize it to other scenarios as well. But
yeah,
when at the first glance of this problem, I think, oh, where should I start? Such a big problem.
yeah. Although, at the end, all you do is you have your data and then you have your dependent variable, your labels. So I guess it doesn't, in some sense, some of the things it's true, the actual cause of the problem could be various things, but I guess the data ends up being fairly similar across the causes. But it's a good point that you're noting. Yeah. I mean, I guess you could have experimented if you wanted to, like if you knew different causes for the problem, you could experiment. Should you break the problem apart or should you keep it separate? I mean, so I guess one thing I realize now that we're talking about it, you could do an EDA at the beginning, right? To look at different causes to begin with, to see if there are differences. Like you could imagine that Android has a problem. I mean, we often have this, right? And different systems have problems. So like it could be like it's an Android issue. Like it's like
Mhm.
so I guess I realized I didn't mention it and we did, but yeah, I guess you could figure that out in an EDA, an exploratory data analysis.
Oh, nice. That's
Yeah.
helpful.
Yeah, but I think at the end for this problem, it seems like you could build a model no matter what. It's just you're right that it may not work. And the reason it may not work is because we have different causes for the problem. And so it's possible, they oppose each other or something. It messes up the model in some way. But I did see that you got hung up on the causes, but it seemed like the model is all the same to me.
Okay.
But I think in general, you're right. For these kinds of problems, often they're vague and you need to narrow it down. And so I think it's fine to pick something to narrow it down. Yeah.
Thank you. Like what do you expect when you answer that question?
I think basically what I was thinking is you have a whole pipeline, right? From data ingestion to the processing of the data to model training to then outputting the particular value. In this case, I was thinking about the model training part. Because assuming you mentioned that you would have to retrain it every so often anyway. So I guess I was thinking end to end in that way. But you're right, end to end is kind of vague.
No worries. Thank you. Hazar, I noticed many companies have this question. So what do you think they are asking for when they, sorry.
Yeah.
Yeah, can I do it again? Azara, I noticed many companies have asked these questions. What do you think that they are seeking for while they are asking this question?
Yeah, I think that's a good thing to ask for. Um, I mean, I think when you see this question, you had mentioned too, I think this particular question is interesting because it's not your standard, I'm trying to increase revenue kind of thing. It's like something that's like a problem that's occurring. So to me, the one thing, if I were asking this, it's asking the interviewee something that maybe is not as typical in the books and stuff. So I think that's one thing is, catch them off guard. The other thing, like you had mentioned, it's a little vague. So can the interviewee kind of focus in on what's important? Um, I think another element just, I mean, we went through everything that was important, right? So as a data scientist, do you know how to do every step? I think probably the biggest thing uh, for these kinds of questions is really, do you understand like overarching importance? So the metrics, but also like what are we interested in? Revenue, these like something about the business, what they're interested in, and an understanding of the business problem. Actually, I think we didn't discuss that as much, but I think sometimes for these questions that's important, right? To have an understanding of the business. And so just what I mean by that is, some businesses are subscription based. So actually, we didn't talk about that, but I don't know if DoorDash has it, but I know Uber Eats has like a subscription you can also get to get cheaper orders. So,
Mhm.
knowing that stuff about the business, I think is kind of helpful. So basically, I've said many different things. I think one thing is just, there's so many elements of the ML systems design problem, and I think knowing that problem well and all those elements to it, like training um, and A/B testing and these sorts of things. And the second point is just knowing, what are the business problems? Like we're interested in revenue. Can you understand from a business standpoint at a high level what's going on? And then the third thing is just knowing that business. I actually think we didn't discuss that as much in this one, but I think if I was interviewing, at whatever company I'm in, I'd want to know that you know my business well. You know whether we have a monthly subscription, we do pay as you go, these sorts of things, because those business models will influence kind of these ML systems design as well.
Great.
So thanks so much, Xinyu. It was really great working with you on this problem. It was a lot of fun. For those of you watching, please feel free to leave a comment, whether you like it, dislike it, or other things you might think of. And you can check out more questions like this on Interview Query, hundreds of them. Look forward to seeing you all in a future video.